Hello. So in this section, I'm going to talk about probability and different parameters comes under probability and probability distribution and conditional probability. So moving further, let's first talk about what is probability. So before I'll discuss probability, let's understand a experiment or any random experiment on basis of any kind of data we should understand. So first of all, what is random experiment? A random experiment is an unpredictable outcome of an experiment is known as a random experiment. Like if I say we toss a coin, either we'll get an outcome either head and tail. Either we roll a dice once, we will get any one of the number that is 1, 2, 3, 4, 5, 6. We toss a coin twice, we can get either 2 times head or head and tail and tail and head and tail and tail. Either we play a lottery, we either win or lose. We take a rest, we pass or fail, we select a student, male or female. So these all are random experiment that we do. Now, in order to understand probability is an event that is defined as a ratio between a favorable case of an event and the number of outcome of an experiment. Like, let's suppose we have any so let's suppose in an exam we written exam and the percentage of getting pass is it's my experiment that is 90 by 100. So 100 is my total sample space and this 90 will be my favorable outcome. Here, as I said, probability is out of any event is being defined. So the ratio between the favorable case to an event and the number of outcome of an experiment is called as the outcome is a probability for a sample out of the sample space of favorable condition. Moving further, we can understand that probability can be defined with more in a compound event or a collection of an outcome of an experiment. Or we can also say that any event that include one and only one of the final outcome of an experiment is called as simple event and is denoted by E. Now, in order to understand conditional probability and other experiment, we can understand that this 90 by 100 is nothing but n by m. So when I say n by n, that is your favorable outcome and sample space. So the same way, if I toss a coin, so either we will get the probability of getting head will be 1 by 2, or if I roll a dice, so what will be the probability of getting even number? So probability of getting even number will be 3 by 6, right? Now, what is complement probability? So this is, let's suppose, called P of A. So what is P of not A? Means what is the probability that a person will not pass? So can I say that probability of not getting pass is nothing but 10 by 100 for this? So that means that is nothing but m minus n by m, because that is 100 minus 10 by 100, right? So probability of not getting pass can be called as nothing but 1 minus n by m, and that means probability of A complement is 1 minus P probability of yes. So we can say that the joint probability will always remain 1. So our probability will always lies between 1 only. That's what I'm trying to say that. So probability, as I said, is a numerical measure of likelihood that a specific event will occur. So the first probability is always lies between 0 and 1, and this is the event lies between 0 and 1. And the second probability, the sum of all properties of a simple event or final outcome for an experiment, denoted by P E naught, always 1. That's what we discuss. So we discussed that probability of two or more outcome or event that have same probability of occurrence are said to be equally likely outcome or an event. So 1 by total number of outcome for an experiment, and probability of A is number of outcome variable to A and the total number of outcome of an experiment. We can understand few more things in this way. So let's suppose we have two different probability, conditional probability. From here we're going to discuss about. But let's suppose if we have a mutually two exclusive event happening. Okay, so if any two mutually exclusive event are happening, so for in this case, an event that can't occur together are said to be mutually exclusive event, and two events are said to be independent if the occurrence of one does not affect the probability of occurrence of the other. In other words, A and B are independent event. So there would be some independent event, and based on that we will find out the condition probability, and there will be some event that will be dependent kind of probability we will have. So let's suppose if we have any dependent probability is there, or any complement of probability is there. So let's suppose we're trying to understand if it's a dependent probability, that is called, let's say, probability of A union B, means two different probability is there. So probability of A union B will be probability of A plus probability of B minus probability of A intersection B. That means this. So A and B, and this intersection is nothing but this one, and we have find out this union. So this intersection is, if I say like this is nothing but this part, intersection B.